Now that we've started talking about limits, it's a good time to give you a preview of the rest of calculus. So one of the central questions in calculus is finding the area under a curve, right? So this is an unusual shape, and so there's not really any set formulas to calculate it directly. It's not a rectangle, it's not a trapezoid, and finding areas might not seem that important, but it's actually really important to a lot of applications. So for example, if you know the rate that oil is spilling out, finding the area under a curve is going to be the total amount of oil that's spilled. That's something that's pretty important to know. Okay, so what does this have to do with limits at all? Well, what happens is that we can actually try to estimate this curve by using rectangles that you can see down here. And the idea is that calculating area of rectangles is really easy. And the more rectangles we use, the more accurate our estimation will be. So what we're going to do is divide up the interval into more and more rectangles, which means they're getting sort of thinner and thinner. They're getting smaller and smaller. And we want that width, the limit, to go to 0. So we want our rectangles to be so paper thin. And then that will actually give us a very, very accurate answer to the area under that curve. And this was the whole idea of how calculus even started. This is what Newton and Leibniz were working on, was the area problem. And then from that, what we call the integral, they developed sort of backwards. They developed the derivative, and then before that, they developed limits to formalize everything. Okay, so here's a more concrete example. Okay, so we have this curve, x squared plus 1, and we want to estimate the area between on the interval 0 to 3 by using these 3 rectangles. So this first rectangle, you can see it will have width 1. Each rectangle actually has width 1. And the height here is the height when we plug in 0, which is also 1. Okay. The next rectangle will have width 1, and the height will be 2, because that's what happens when you plug in f of 1. And then the third rectangle has height, it looks like 5, and we'll check that by plugging in f of 2. Right. And we get 2 squared plus 1, and that will give us 5. Okay, so the first rectangle has area 1 unit, and then the second one has area 2 units, and the third one has area 5 units. So overall, it seems like the area under the curve is about 8. So we can see that that is an underestimate because, for example, we're missing all of this area in red. So that's going to be a lower bound. And if we made our rectangle skinnier, it would give us a better estimate. Now, this is something called a Riemann sum, and we're going to talk about this more. It'll probably be a couple months. So this really is a preview of what we'll be working on this semester and what calculus is all about.